This is day 2 on Chapter 4, Section 5, titled Graphing Linear Equations in Standard Form. So remember that standard form again, as we had talked about yesterday, is in which we see ax plus by equals c. And so what basically we see is the x term and the y term are on one side of the equal sign. The constant is by itself. And when it's in this form, we can use intercepts. And we talked about intercepts yesterday, how the x-intercept we end up setting y equal to 0. X-intercept we set y equal to 0. And for the y-intercept, we're going to end up setting x equal to 0. So let's practice that on these problems. We'll find that x-intercept first. And again, you're going to set y equal to 0. And so it'll cancel out that 3y, that minus 3y, leaving us with 2x equals 12. So when I divide by 2, I get an x value of 6. What that is 6, 0. It's a point on the x-axis. And so I can't make it quite over to 6 here, so I'll just go ahead and maybe go by 2's. 2, 4, 6. So this is 2, this is 4, this would be 6 right here, this would be 8. So I'll put a dot right there. And then I'm going to find the y-intercept. For the y-intercept, I'm going to set x equal to 0. So it's going to cancel out the x term, leaving me with negative 3y equals 12. When I divide by negative 3, I'm left with y equals negative 4. So that point is 0, negative 4. And so if I go down 4 spaces, 1, 2, 3, 4 on the y-axis, I put a dot there. And actually, since I had gone by 2's, let's go ahead and do that again. Let's call this one negative 2. This is negative 4 right here, negative 6, and so on. So I'll go ahead and put it right there, negative 4, and then draw the line between those points, and that's what I get. So let's take a look at the next one here. This is definitely one which we'll have to change the intervals on our graph, because if you take a look at the x-intercept, when I set y equal to 0, I'm left with just with x equals negative 27. That's the beauty about the xy-intercept method, or the standard form method, is that sometimes when x is by itself or the y is by itself, you can find out what that intercept is quickly. So this is negative 27, 0. So I'm going to count, if I go by 3's, I don't quite have enough, so I think I'll call this one 6 spaces right here. And so this is negative 6, this would be negative 12, negative 18, negative 24, and then negative 30 would end up going right here. And so from there, we'll be able to fit our value. So we'll go ahead and put it halfway in between negative 24 and negative 30 there. And that's where our first point is, at negative 27. Now the next one, though, we have for the y-intercept, I'm going to set x equal to 0, so I'm just left with that 9y equals negative 27. So if I divide by 9, I end up getting y equals negative 3. Now I could end up going by 6's again, and that would show how, or exactly what that slope would end up looking like if I had gone by 1's. And so 3 would be just half a space up here because I'm going by 6's. And so, and let's see here, it was negative, so let's go ahead and change that real quick. So this is 6, but down here is negative 6, and so I'll go right about there, and I'll draw the line between them. And the nice thing about using the same intervals on both the x and y axes is that you really get a better understanding about what that slope ends up looking like. It'll really match what the actual one is, and instead of using different intercepts or different intervals, and then the slope will be a little skewed from what it would actually look like. So looking at the next one, we got some fractions to deal with, and that's okay. And so we're going to set y equal to 0 first. That'll find our x-intercept. So we're left with 1/4 x equals 1. So here again with fractions, it's nice because we can just multiply by the reciprocal on both sides. And so you see if I do that, the 4's cancel out, so I'm left with x equals 4. So this point is 4, 0. So I'll go over 4 spaces. 1, 2, 3, 4. Put the dot right there. And then move on to the y-intercept. I'm going to set x equal to 0. It's going to cancel out this x term, left with 3/4 y equals 1. Well, this one's not going to work out as cleanly, but it's again easy to deal with getting rid of the fractions at least, because you just multiply by that reciprocal. So when I go ahead and do that, I'm left with 4/3. And 4/3, here's where mixed numbers come into play. We want to understand what 4/3 is. Well, 4/3 is just 1 1/3. And so this is 0, 1 1/3. And so I'll go 1 1/3 up. So it's going to be a little bit above that 1 and then draw the line between those points. So that's what those problems look like. Let's take a look at another one here. Here it says you go shopping and buy X shirts for $12 and Y jeans for $28. So the first thing I'm going to look at is, okay, they're telling us what variable to use for X, or what our X should be. And so it's the number of shirts, X shirts for $12. X shirts means number of. And so that's going to tell me that I'm going to end up using number of shirts for my x-axis. So let's do that. Number of shirts. And then it says Y jeans. So that's the number of jeans. Number of jeans. And so I'll go ahead and write down number of jeans on the y-axis. And so from this point, we're going to end up having to write an equation. Now let's see what we've spent. We're going to spend, okay, so you go shopping and you're going to spend $12 on shirts, $28 on jeans, and you have a total of $84. So we've got $84 to spend. We can buy two different things. We can either buy shirts, a number of shirts, but since we're spending some money, we can't just get those shirts for free. We've got to spend $12 per shirt. So if I multiply 12 times the number of shirts, that's going to give me how much money I will spend on just shirts. But then we could buy some jeans. We could buy some jeans for $28 a piece. So $28 times the number of jeans we buy would equal 84 once I add it to how many shirts I end up purchasing. So here's our equation that we have. Now we're going to go ahead and solve. And we're going to use this intercept method because, again, I've got x and y on the same side. It's a quick way to do it. And also the other thing is we're not going to have any negatives. So we cannot have negative jeans or shirts, and so that's why I end up using just the first quadrant in this. And again, the intercept method will help us out because it's going to tell us how many jeans we can buy or how many shirts we can buy. So let's go ahead and solve. And so we're going to end up starting with finding the x-intercept. And I'm going to set y equal to 0, set the number of jeans equal to 0, saying that I bought no jeans, and then solve for how many shirts that would be. So I go ahead and do that division, and x is going to be 7. So 7 shirts when I buy no jeans. So the x-intercept is 7, so this represents x-intercept means I can buy 7 shirts without buying jeans. So if I don't buy any jeans, I can buy a total of 7 shirts. So let's go over 7 spaces. 1, 2, 3, 4, 5, 6, 7. I'll tell the reader that's what I'm doing here by putting in some numbers on my graph. Oops, this would be 10 instead of 9. And then let's find out what that y-intercept is. So 7 shirts was the answer for the x-intercept. For the y-intercept, and the y-intercept is going to be when I set x equal to 0. X equal to 0 means that I'm not going to buy any shirts. Let's find out how many jeans we can buy. 28y equals 84. So when I divide by 28, I end up getting 3. So y equals 3. And so what that means is, for the y-intercept, means I can buy 3 jeans without buying shirts. So I can buy 3 pairs of jeans if I don't buy any shirts at all. And so I'll go ahead and put in some intervals here so the reader can find out what my number represents. Put that y-intercept on there, and let's see, jeans Y, X is shirts, and then go ahead and draw the line between those points. So there it is. And so again, what that represents is that I can buy 7 shirts without buying any jeans, or I could buy 3 pairs of jeans without buying any shirts. And I can buy anything in between as long as it ends up being a whole number. I can't buy a half of a pair of jeans or anything like that. Those would be the different solutions I could end up having. So those are the types of problems you'll see on tonight's homework. Good luck.